Hey everyone, so today let's try to solve this problem called robot collision, which is another hard problem that I'm trying to explain. So basically in these problems you are given a bunch of robots. So each robot will have a positions, and each robot will have health, and each robot will have a direction. So let's assume that we have a robot of size 5. So you can see there are 5 robots here, 1, 2, 3, 4, 5. So each of the position will have a length 5, health will have a length 5, and direction will have a length of 5. Because like, so for example, this particular index represent the third robot position, and it is at position 3, and the health is 9, and the direction of it is arrow. So now we have a bunch of robots basically, and each robot will have a position, it will have a health, and it will have a direction. So what the problem is asking is that, so if they go left, and then some of the robots will go left, and some of the robots will go right. So assuming that you are at a certain position, for example, some robot in here, it is going right, and there's another robot in here, which is going left. So in that case, these two robots will collide. So what the problem is asking is that once they are having a collision, the one with the bigger health will survive. So the other one will die. However, after the one survives, the health will actually decrease by 1. So that's the whole problem. So let's take a look at the first example. We have this position 5, 4, 3, 2, 1. So it's basically this example. So all of the direction is going right. So there's no collision if all going right, because there is no robot on the left hand side that is going to collide with this current robot. So in that case, we will just return the original health because nothing has collided. Okay, let's take a look at the second example. So after visualizing the position, health, and direction of each robot, we'll get the graph look something like this. So at first, we can see this robot will actually collide with this robot, right? So as a result, because they have the same health, as in the problem statement, it said if they are having the same health, they're both going to die. So now this two is going to die. Now let's take a look at the next step. After they die, this robot will actually collide with this robot, right? Because this is on the right hand side going left, and this is on the left hand side going right. So if they collide, 15 is actually greater than 12. That's why this one will die as well. And then this one will become 14, right? Because it survived in the collision. However, as we already mentioned, if it survived, it still has to decrease the health by 1. So that's why we are having this. So that's why we are having this 14. So that's why the answer here is 14. So let's take a look at the third example. So in this third example, after visualizing the input, it will look something like this. So first of all, these two we're gonna collide because they're having the same health. So both of them will die. And these two is gonna collide as well because you can see this is obviously they're gonna collide because this is on the left hand side but going right, but this one is on the right hand side but going left. So that's why it's gonna collide. So that's why every robot is die. So that's why it just return the empty input. So that's pretty much all for the problem statement. And let's think about how can we solve it. Okay, so let's try to think all the robots not in the order they are given, because it is kind of meaningless to just look at the order they're given because it doesn't tell us much. Instead, probably is better for us to look at the robot according to their position. So basically, we will just sort all the robot first by the position. Then we're going to visit the leftmost position first and all the way to the rightmost position. And that's actually not enough. There's another trick that we have to use, which is we need to use the data structure called stack. Basically, when we are traversing from leftmost to rightmost, if it is going right, then it's fine, right? Because we are going from left to right. And if it is going right, it doesn't mean that it will not have collision. It just means that even if it had collision, it will not happen on the left-hand side because it is going right. That's the key one. Because we are visiting from left to right, that's why even if it had collision, it wouldn't happen in the previous. However, we do need to kind of store this thing into a stack. So to notify us if later something happened on the right and it is going left, then it means that we have to pop some of the stack. So for example, if I am visiting from left to right, and these two, I just store them in a stack. And then now I visit this thing. So it is on the right hand side of these two. So basically at this point, so this is a stack storing these two, basically, you can imagine. So, and when I'm visiting this current one, and it is going left, what does it mean? It means that I have to pop some of the stack because all the things on the stack are going right. And if it is going left, I need to pop some of the stack. Of course, if there is nothing on the stack, for example, there is a robot here and then nothing on the left hand side and it just go left. So that just means there is nothing to match. So otherwise, if there is anything, I don't care what their position is, they're gonna have collision somehow in the future. So let's back to this example. When you go to this particular robot and it is going left, and it means that we have to check for the stack. So first we're gonna check the top of the stack, which means the rightmost one that's gonna collide first. It also means that this is the first robot that we're gonna collide. So you're gonna check the health. So if in this case they are having the same health, then I'm both gonna delete it. So let's assume it is not having the same health. So this one, let's say it's 9. And then after they have a collision, so this one will die. So this one will actually become 9, right? Because if they have a collision and this one survived, and the survivor will decrease the health by 1. So we have to keep doing until the stack become empty or this current one die. So in this case, now 9 versus 15. 15 is larger than 9. So we're going to erase this. So this thing becomes 0. Actually, the health becomes 0. And then this one will just become 14. So we have to keep track of the index of each robot so that we can decrease the health in here. So after doing all this kind of stuff, and then we're gonna check if there's any robot that has greater or equal than 1 health, actually greater than 0 health. If there is greater than 0 health, then we're gonna include that in the answer. So if it is not, then we're just gonna ignore it. And then we do them on the same fashion that we are given the orders, just like from left to right. So that's how we're gonna maintain the same order that the robots were given. Okay, so in general, we're just gonna use sorting and then stack to solve this problem. So that's pretty much all for the approach. Let's see how we can implement it in code. First, we're gonna initialize the size of the position as n, and then in this line that we just try to make the position also with the index. So for example, if the position it's something like 1, 2, 3, and this error will just become 0, 1, and then 1, 2, and then 2, 3. So basically we do this so that we can maintain the index information that we later need to kind of change the health of the original index. So first of all, we're going to sort the robot by its position. So that now we are considering the robots from left to right. And then we're going to initialize the stack that we mentioned. And also this is our answer. We're going to initialize that here too. So for each index and position in the robot, so if it is going right, then as I mentioned before, even if it had collision later, it's not happening right now at this moment. So we're just going to append it in the stack first. We're going to deal with it later. And otherwise, if it is going left, and also if there is something on the stack, it means that this current robot will have some collision, right? So first case we're going to check if the health of the robot on the stack is actually having the same health of the current robot, then both of them will die. So I'm just going to mark them as die by setting their health as 0. So if they are just both died, then I will just break the loop. Otherwise, if the current robot loses, it means that so the health of the top of the stack is actually having larger health than current robot. So the health of the robot, even if it survives, the health has to be decreased by 1. And then of course the current robot health will be 0 because it died. So we're going to break as well because the current robot dies. And otherwise, if the current robot actually wins, then the health of the current robot will decrease by 1, and then we also have to pop the stack because this robot died, and also the health becomes 0. And notice here we don't break the loop because we have to keep considering until the stack becomes 0 or until the current robot die. So now that we have considering all the health and make the adjustment of the health if necessary. So on line 23, that we just going to visit the original order. So if the health of this one after all this collision is still greater than 0, then we're gonna append the health of this thing into our answer. And eventually we're just going to return the answer. So in this approach, on line 2, the time complexity is O(n) log n because of this sorting on line 6. And the space complexity is O(n). There's pretty much a bunch of ways that we have used space O(n). So the first thing is the list on line 5, and also even if we don't consider that, we still need to use the stack on line 7. So the space complexity of this solution has to be O(n) as well. So let's try to run this code. Okay, accepted. So that's pretty much all. I hope that's helpful, and I'll see you next time.